useState versus useRef. When should you use state over ref? Well, for that, we have the simple rule of thumb. Use ref when you need to keep state, but you're not going to use it for rendering, including derived state. And use state when you need to keep state and use it for rendering data. And this and is important. If you just need to keep track of something, but you're never going to use it for rendering, you should always opt in for useRef. However, let's quickly recall what each does. useRef stores mutable data, which you can access via the .current property. Now, when we talk about immutable, we mean data that can be modified or changed after it has been created. That's why you can say .current is equal to 5. You do not need to call any set or any function. So this is mutability. However, when it comes to useState, you need to use a setter to update the value of useState. Hence, the value of the state is immutable and not be modified or changed after its creation. Now, how come useState is immutable? Why do you need to call this setter? Well, that's precisely the pitfall of useState, which causes a re-render. So the idea behind this setter is to re-render the component. And this is important for React because by re-rendering the component, it can update or identify which elements must be updated. But why is it a pitfall exactly? Well, it's twofold. One, because if you're not going to use the state for rendering, in other words, you're not accessing it in the JSX rendering, aside from callbacks and event handlers, obviously, every time you update that value, it is going to re-render your component. Now, do not be afraid of re-rendering. Re-rendering is completely fine, and you shouldn't try to minimize the amount of re-renders. But this can be problematic, especially if you're using this state in a useEffect, and then you run into the infinite useEffect problem, or just for the mere fact that if you need to keep track of a value and you're never going to render it, why do you need this unnecessary re-render? You can just use useRef and avoid that altogether. However, the second problem, which is a pitfall I have witnessed firsthand in actual production code, comprised of a team of developers, is misusing useState to force re-renders. What I mean by this is they declared this hook called useForceReRender. They initialize some state and then they return a function that all it does is invoke the setter, and it simply increments the value by 1. Now, since we know that by invoking the setter of a state, it is going to cause a re-render. So in fact, this value doesn't matter, nor this one. As long as you invoke the setter, it is going to trigger a re-render. Now, why did they do this? Well, they did this because this allowed them to have mutable data. So they declare the data with a useRef, like we have here, so const counter, we initialize it with 0, and then we have this function increment counter, and then we simply add 1, so we increment the counter by 1, and then we invoke the force re-render function, which again is going to invoke the setTick. And so with this, we can say counter is equal to counter.current. So as we know the useRef, when we change the value, it is not going to trigger a re-render. And again, it's because it should not be used for rendering data. But they use this hack by using an internal state that is going to force a re-render. And every time they updated this state from refs, they invoked force re-render over and over again. Now you may be wondering, does this really work? Well, of course it does. As you can see, we have the counter, which is 0, so this is correct. And if I click on increment, it is incrementing this state. And in fact, well, if I inspect element and then open up the extension for React, as we can see, we have this ref, and it is at 11. So obviously by invoking this function, it is triggering a re-render, which allows you to have this state. So what is the solution here? Well, use useState as it is intended. So if you see this in the wild, make sure to correct the developer. Anyway, with this, let us move on to some practical examples of when a ref is better. For this one, let's imagine we want to send some analytics data. So you need to keep track of how many times a button has been clicked. Perhaps you have a subscription plan, and when the user clicks on the button, they get the dialog, and then you want to track how many users click on the cancel button or close the dialog in general. Well, for this, you need to keep track of, say, the button clicks to know how many times maybe the user was compelled to subscribe to your plan, but in the end they didn't. Obviously, this is a hypothetical situation, but this showcases why ref is better than a state. So here we have this mock send analytics data function, receives data unknown, and then simply alerts it. But here we would do a network request, or at least batch them. And then we have the button clicks, set button clicks, so 0 at first. Then we have this function on button click. We set the button clicks to previous +1, and then we send the analytics data. And here we have a bug, which I'll show you in a bit. And then we have the button subscribe, and then unclick with this function. Now, what is the first bug here? Well, React dispatches the setters. So when you invoke set, it is not going to reflect immediately the new value here. So when you send the analytics data, you're actually sending the previous value and not the updated one. And we can confirm this if I come here and click on subscribe. As we can see, button clicks is 0. Is this true? It isn't. Because if I come here, the button clicks is set to 1 here. Although this is very small, let me make this bigger so that you can see better. Here we have hooks state 1. So here first mistake is doing it sequentially. So what we need to do is come here and we can say const new value is equal to prev +1. And then we can move this function here and we can say button clicks is the new value. And we can return the new value. That way we can ensure that the state or the data that we're sending here reflects the most updated one. So if I save this and then come back here, click on subscribe, we now get 2. And if I come here, it says 2. So again, subscribe 3, and then if I come here, we get 3. Now you might be wondering, why are we getting this dialog twice now? And the reason is because I have a strict mode. So react.strict mode, this one right here, it is going to force a second re-render just to make sure that everything is working as you expect it to be. You can read the reasoning in the official documentation. But now we're not using the actual button clicks. We're just using the setter. And then upon update, we send the data. So here we're re-rendering the component unnecessarily. If I change this to, or rather if I comment this out and then save this and then come back here, every time we click on subscribe, as you can see, it is re-rendering the component. So re-renders over and over again. And this is not necessary whatsoever. Now I told you do not worry about re-rendering, but if you have some logic here, maybe you have some derived state that is doing something expensive, then you're rerunning that every single time. And that is not ideal. So this is the prime example of preferring ref over state. And again, rule of thumb, are you using this state value in your JSX rendering logic? If you're not, change this immediately to a useRef. So you can say useRef, then keep it at 0, and then you can say button clicks, and instead of doing all of this, you can say const new value is equal to button clicks dot current plus 1. Then you can send the data and then you can replace the current with the new value. And if I do this, and then let me bring back the alert. If I save this, then come back here, click on subscribe. As you can see, there were no re-renders and we get the updated value. So again, subscribe, no re-renders. If I come here and say console.log rendered, hit save, then come here to the console. As we can see, we get the initial render. And then if I click on the button again, there are no additional renders. So this is quite easy. We're just using the ref value within an event handler. We're not using it for rendering actual data. Now let's take this a step further. You need to batch the requests. So you want to invoke this function, which internally does an HTTP request after there has been a period of rest. So for example, we have the subscribe button. Let's say the user may be able to spam this button. So this is some sort of the bounce, but at the same time, we're batching them. So we click on this button, we get 1 and then click again. But well, this wouldn't have an alert. So if I save this and then spam this, it is going to perform who knows how many requests. So for this, you can use a ref that is going to store a timeout. And that timeout, upon expiration, so once the time has passed, we'll invoke this function. Otherwise, every time we click on the button, it is going to reset the timer. That way we're batching them. So for that, we can say const timeout id react.useRef. The type will be node.js.timeout or null, since at first there is no timeout. And then we can say null here. And then instead of invoking this function here, what we can do is say timeout id is equal to set timeout. And then we invoke this function, but only if 5 seconds have passed. And here we should reset the button clicks, of course. So button clicks dot current is equal to 0. Now at this point, it is not really doing anything because we're not resetting the timer. So what we can do is say if timeout id dot current is different from null, then we should clear the timeout because we want to reset the timer. So we can say clear timeout and we pass in the ID. And this is actually dot current. And with this, now we can alert the data. And theoretically speaking, if we click the button multiple times and then wait for 5 seconds, we should get that alert. So if I come here and then spam this button a couple of times, and then if we wait 5 seconds, as we can see, we get button clicks 15. So again, twice, it should now be 2 instead of 15. And as we can see, it has been reset successfully. So this is what you would use refs for. You wouldn't use a state here. But now let me introduce you to another powerful usage of useRef, and that is acting as a memoization technique. So let's imagine we have a useEffect. So react.useEffect, we have a function, and let's suppose we have some data that we're fetching from a query. So like a use query from Tanstack query, but in this case, we can say data is equal to, and let's imagine we have an array. So use query. So we're getting some data here and that returns an array of elements. And if you have used this library before, you know that they have removed the unsuccess callbacks. So for that, you would have to resort to useEffect. So you could say every time data changes, we can do some logic here. So console.log data. And let me say this will be an array of unknown. So Weslint stops yelling at us. And with this, let's say we have the dupe, the data, and it is going to set something. So let's have a function here. Let's say function update data takes in the new data, and then we can have a state. We can say this will be query, dedupe the query data, and here we can say data, set data, and then set data, we pass in the new element and we have this function, and then we can render the data. Obviously this is all hypothetical, so it is not going to do anything, but just for demonstration purposes. So if we have this and then we invoke the function, so after that we update the data and we pass in the query, and this is going to trigger a re-render because it is invoking set data. So if I save this and then come back here, look what happens. We get an infinite useEffect loop. And you might be wondering, why does this happen? And before my browser crashes, let me close this. And that is because we are calling this a data. And since this is a state, it is going to cause a re-render. Although, since we're using update data, we should also set it here to the dependencies. That way it is correctly synchronized. And if I was using slint, or rather a configuration for React, it would have told me to update this dependency array to include update data. Now this wouldn't throw an error per se, because this would be a react.useState and then an empty array. And then you can say query and set query just for demonstration purposes. So what this is causing is, since this is invoking this function is being re-rendered. So it re-renders and re-renders over and over again. That's why we get this infinite loop, because we set this function in the dependency array. And we know that whenever any of the items specified within this dependency array will cause the useEffect to run again. So since the set call will cause a re-render, this function will be recreated from scratch. And so we get this infinite loop. So what can we do here? Well, there are two solutions. The first one, and if you read the React documentation, I'm pretty sure they have an example like this, is to wrap this up in a useCallback. So you can say const update data is equal to react.useCallback. You pass in the arrow function, or well, the callback here, which is the equivalent to this logic right here. And then you can have an empty dependency array, so this function will never be recreated. And that way, if we do this and then come back here, as we can see, it now works. It is not triggering an infinite loop. But the other solution is to use a ref. So you can comment this out and you can say const update data react.useRef, and it is going to hold a function. This is the equivalent to this one. So a useCallback with an empty dependency array is the equivalent to this. So to a function that is stored in a useRef. But if you do this, well, to invoke it, you have to say .current, and the current is the function itself. Now, is this recommended? How does it differ from useCallback? And the answer is, at least from my research, they are the same. You can use whichever you want. Now, I would prefer useCallback because after all, it is designed for that, to store a function that shouldn't be recreated, or at least as per the dependency array. A useRef is simply for storing state that will not be rendered. So even though the two work, and you can use these two interchangeably, as long as the dependency array is empty, it will be fine. But again, use useCallback, just to be more explicit. Anyway, this wraps up the video. If you want to see more content like this, make sure to subscribe. I'll see you in the next one.